going to try something a little bit new today, guys, and that is also new to me. So please be patient as I try and figure out how to use this particular program. So Kahoot, I've got a small quiz set up to kind of see where everybody's at as far as, for the first one, we're going to be working with decimals. And there's 2 of each question. So we're going to go ahead and get started. Everybody is ready? Yep. Not connecting at all? Alright. You get a minute per question to give it a shot, guys. So here's your first problem. Calculators, you can put it on a pencil and paper, whatever you need to do, guys. So I'm just trying to get a feel for where everybody is with decimals. Most of y'all said 11.76. That is correct. Okay. I don't know what the points are for, but we're going to go with it. All right, here's the second one. 3.25 plus 2.303 plus 4. I guess I did a lot deliberately out of it. Everybody's locked in their answers. Alright, looks like there was some confusion on this one. The answer was between 2 different ones. You had 9.553 and 9.55. Did that kind of deliberately. But both answers would have been correct. Okay. So the next one, subtraction. 14.02 minus 10.086. Guys, do not stress about points or anything like that. I'm just trying to get a feel for where everybody is and what we might need to cover more thoroughly. And the correct answer was 3.934. Okay. I Might have to use this program more often. All right, so 10.6666, 4 sixes after that, minus 5.3 with, and there's 4 threes behind that one. Okay. Everybody's got it? And everybody's right. All right, next one, 3.1 times 2.7. Okay. Looks like a lot of y'all got it right at 8.4. Okay. Any questions on that one real quick? Okay. 0.24 times 3.12. All right, and everybody got it overwhelmingly correct at 0.75. And guys, I'll go ahead and say this. I'm not one that generally puts a 0 in front of my decimals unless I'm doing currency, simply because I've never really seen the point. I know some people do it because it makes them feel happy to have that placeholder there. I've never been one much to do it, so. $2.5 divided by 1.7. Okay, 1.5, everybody gets it right. All right, 15.50 divided by 3.1. All right, and everybody gets it correct at 5. Okay, and that is the end of this, guys. I can interesting way to do that. Okay, so, and we'll come back and we'll do this again with ratios and proportions. Okay, so the whole point of that was to kind of get an idea of where everybody was when it came to what we're going to be going over tonight. So give me just a second. For some reason, my computer just kicked me off my own network. So tonight we're going to be going over 2 subjects. The first one will be decimals, and that's what this current bit will be going over. And then we will be going over ratios and proportions, which will be what the next video covers. And the whole reason we're kind of going over the quiz before we go into it is to kind of get an idea of what everybody knows, get an idea of what everybody kind of remembers from when y'all had to do this before. Because everybody remembers all that, don't they? Every last bit of it. Yeah, I know most people have a hard time going back and going, decimals, decimals. When did I do that? Just about. 4th, 5th, somewhere in there. Long, long time ago for everybody, right? So we're going to kind of fly through some of this. I think y'all did pretty well with the adding, right? So I don't know that we're going to go too deep into adding. So everybody knows whenever you're adding, it's the best way and best practice generally to line up your decimal points, right? If you're having to add by hand, line, because then you don't start mixing yourself up, right? Because it can be very easy to start mixing your numbers. It doesn't take somebody dyslexic to do it, because just about everybody does it. If I have, let's say, 2.76 plus 5.3 plus 2.103. If I don't line those up, it is very, very easy. We'll say that's actually 12. Uh-oh, all of a sudden I'm really going to have trouble with that because all my numbers are going to be shifting back and forth as I try and add them. So the easiest and best practice is generally line them up, add them up, done. Makes it visually easier to do things. And we as humans are actually very visual creatures. Y'all know that, right? For those of you who've never heard the phrase, you eat first with your eyes, it's a very common saying in culinary that means that if you make something that looks like poop, then chances are your brain's going to sit there and go, no, you ain't putting that in your mouth. However, if you are served something that looks extremely delicious, but it tastes like poop, your brain doesn't translate that as easily. You know what I mean, right? If it looks like garbage, your brain automatically assumes it's garbage. If it looks delicious, your brain assumes it's delicious up until you stick it in your mouth. So I don't trust anything anybody puts in front of me for food. All right, so that is a very good principle whenever you're dealing with anything visual, is just to try and make sense of it in a way that your brain can take care of it, I guess you could say. Okay? And here's one thing I will go ahead and say, and this is actually very useful for the next topic we'll be doing on Thursday. And that is, you can add zeros to the end or to the beginning of a number, never in the middle. The reason I say that is we're going to be going into powers and roots on Thursday. And in doing so, we're going to be moving the decimal point a lot. We have what's called, in that particular set, a floating decimal. The decimal is not it is a fixed value, but not a fixed position. Does that make sense? So we're going to be adding zeros, taking zeros away. The zeros are nothing but placeholders in some areas, and we're going to be moving that decimal a lot. That being said, you need to make sure you understand the principle that yes, you can have zeros added to the end and the beginning of a number, not in the middle. Okay? And you'll see more of that whenever we talk about it on Thursday. All right? So converting fractions to decimal fractions, which I always just say decimals. You set up a fraction by, essentially we all know this. We've all done this before. When we're taking a fraction, we understand that that can also be pronounced as 2 divided by 5. Yeah? We've all done that. Because we've used this little guy right here as the division sign. Instead of the dot slash dot, we use just a slash. So in 2 divided by 5, we go ahead and add our 0 in, which, why is this? I'm sorry guys, I don't know why this thing's freaking out my colors. There it goes. All right, so you would add your 0 if you're doing long division to this. Whenever you add your 0, know your decimal point was right after that 2, so you bring your decimal point up. You do 20 divided by 5 is 4. So you end up with a decimal point 4. Reciprocals. Now, reciprocals is a term you want to keep in mind, because reciprocals is something that we use a lot in the mathematics we do. All right? What it means to take the reciprocal is you take the number and you flip it, just like we were doing in fractions, right? You take the number, you flip it on its head. So the other word for this is taking the inverse. That's another term you might want to hold on to, especially if you decide to take DC. That one gets really fun. So reciprocal means opposite or inverse. To get the reciprocal of a number, you divide the number into 1. So the reciprocal of 5 is 1/5 or 0.2. Is there any questions on that, guys? Any questions at all? Okay. Now, generally, I don't put a lot of reciprocals and stuff like that on the test without y'all being able to use a calculator. Why? Because reciprocals are a bit of a pain. Which, by the way, do y'all know what the calculator key for the reciprocal looks like? Let's talk about this a little bit more in just a second. Most calculators have it one of two ways. They have one. Let's see if I make it from here. Oh, I'll get in a second. One. Okay, Okay, so who's been letting the markers dry out? I don't know. Whoever's letting the markers dry out needs to be ashamed of themselves. 1 over x is one of those keys. The other key tends to be an x to negative 1. Those are your reciprocal or inverse keys. Okay? Just in case you don't know what those look like on the calculator. So if you have a calculator, you need to make sure you know where that inverse key is. Okay? All right, so moving on to addition and subtraction. Everybody good so far? So calculating in decimals, calculating in most things, okay? There's two basic operations, addition and subtraction. You should remember this from elementary or middle school. Yeah? If you're multiplying, you're just adding the same number to itself over and over and over again. Amen. If you're dividing, you're subtracting over and over again until you have a shape. Okay? So we have the commutative law of addition. All this just means that it doesn't matter how you add it, it's going to add up the same. Okay? Doesn't matter how you write it, it's going to add the same. Okay? I don't know who got these slides from the math person, but apparently they got it from the math person. Because they talk about all these laws, and honestly, we don't use them. It's just good to remember that they are there. So you got the associative law of addition, which means that the grouping of numbers, let me put it this way. As long as you're just adding, okay? As long as you are just adding, it doesn't matter what you do to the numbers, as long as you are just adding them together, it doesn't matter if you group them, if you change them around, flip them around, do whatever. If you're just adding, the sequence of the numbers does not matter. However, the second you throw something else in there, like a subtraction, multiplication, or division, that law no longer applies. Does that make sense? Okay. Figure I'd boil that down for all y'all, because all this just gets overly complicated, and I am not going to make it complicated if I can help it. Okay? So let's kind of go to this one. We're talking about addition terms, and the only main one I would say to learn is the word sum. And the only reason I say that is because I was helping my niece with her homework one day, and I could not remember what the word sum meant. Now, understand that that was over a decade ago. I no longer have to help her with her homework. She actually sometimes goes to her mother for that. But the word sum means that you are adding. The other ones are great Jeopardy words. You know, what is the augend? This is the original number to which will be added. Seriously, I don't know why we would need to know that. The main term I ask that you learn is the word sum. That just means you're adding something together. Is for the answer to the equation. So here's a quick practice problem for y'all. Just see how comfortable you are with the adding. Everybody good? And that should be your sum. Everybody good? Questions? Well, I can see where that might happen if you forget to track your number over. It's adding, working with decimals is very easy to misplace your numbers. It happens all the time. So for most of this particular problem, you just drug everything down. 6 and 2 is 8, 5 and 3 is 8, 5 and 1 is 6, 7 and 2 is 9. Then we get to 8 and 3. So 8 plus 3 is 11. You carry the 1 and you become 1196.88. Okay? Everybody good? All right, so to subtract, we do the same similar thing. You align everything. And you have to remember borrowing. Now, borrowing is where things get complicated, right? Borrowing is one thing everybody dreads with subtraction. Why? Because if you don't track your borrowing and subtraction, it can, will, and does bite you. Doesn't it? So the very first thing, we start always going from right to left in a problem. We start at the end and work our way up. So we might subtract 8 minus 5, which would give us 3. But we cannot subtract 6 from 3. So we borrow. We look to the number in front of the 3, and that is a 1. We cut its value down to 0, move it to the 3 as a 10, and you get 13 minus 6, which would give you 7. Okay? So then we've got to, well, I skipped ahead of them a little bit. All right, so the next one we've got to look at is we've now got a 0 where our 1 is. All right, we cannot subtract 4 from 0. We borrow from the 2. The 2 becomes a 1. 1 travels over here. You get 10 minus 4, which would give you 6. Again, it's all just in the borrowing. It's tracking what you borrow and how you borrow. But you cannot subtract 5 from 1. So you borrow from the 8. The 8 becomes a 7. This guy gets 2. You get 11. 11 minus 5 is 6. And then you just bring down your 7. So you end up with 766.73. Does everybody see how that happened? Everybody kind of remember how to do all that? All coming back? The recesses of your memory. Now, again, the only term I would say you should know is difference here. Why? Because you might need help somebody with their homework one day, and they will have the word difference in their homework, and you sit there and ask yourself, what operation am I doing? Sum is add, difference, subtract. Okay? Somebody, if a question says find the difference, it means subtract the numbers. Okay? Bingo words for here are minuet and substitute. I can't even say the second one. That's a math term for strictly math teachers. I trip over that word every time. Again, they're great for Jeopardy or bingo, but if you don't need to use them on a daily basis. So here's another practice problem real quick. Let's see how y'all do. All right. Everybody good? All right. 478.84 should be your total. Your total difference, right? Everybody good? All right. So we're going to talk multiplication and division. So in this case, you do not need to align the decimals. Why? Because it's not necessary. Okay. The term to know on this particular slide is product. Again, it's just the other ones are great Jeopardy words, right? Again, I think this came out of a math teacher. I don't know. Just might be over explaining. I'm not a math teacher that over explains. I pretty much try and give y'all what it is. Okay? But words like product, sum, difference, those are great for, like I said, I have seen this kind of problem terms in my niece's homework. And there were a few times I had to look at it and go, what is this actually asking? Whenever I first saw it, I hadn't taught this at all. And I hadn't remembered any of this from whenever I took this class. So I literally looked at my niece and said, what does it mean to be a sum? What are they asking you? And she looked at me and said, I don't know. Ended up teaching this a couple days later and went, oh, I know what I needed to do. Yeah. Here's the cool aunt that's supposed to help with homework, and she can't remember what the word sum means. It happens. Some of these terms don't stick, but it's good to have a refresher and know what they mean if you ever have to deal with that. So again, commutative law and associative laws, again, all they mean is that as long as that is nothing but a multiplication sign, doesn't matter which order you do it in, it's all the same to it. Does that make sense? Doesn't matter how I stack the numbers, group the numbers, nothing. As long as they're just multiplying, it doesn't matter the order I do it in, you will still have the same answer. But the second any one of these changes to a different sign, add, subtract, or divide, then that particular law goes out the door. Does that make sense? again. I think they got it from the mathematics department. How many of y'all remember decimal multiplication? Used to be fairly easy, right? You take the shorter number and start using it to multiply the larger number, right? So in this case, I would use 69 or 6.9 to start multiplying into 231.54. So I'd start off by saying 9 times 4, 9 times 5, 9 times 1, 3, and 2. And that should get me 208386. And then I would take my 6 and start doing the same thing. Multiply 6 times 4, 6 times 5, 6 times 1, 6 times 3, and 6 times 2. But I shift my numbers by 1. Why? Does anybody remember why you shift the number up by 1? Nobody remembers? Well, you're not dealing with the 9 anymore. You're dealing with the 6, right? So I shifted up a number space, right? Just remove the decimal, and I went from the ones place to the tens place. That means I need to shift my whole number that I'm getting for the second one up one place to accommodate that, right? Does that make sense? Does everybody kind of remember that rule? Yes, no, maybe so? How many of y'all are about to fall asleep on me? All right. We're going to take a break after we get through with this. All right, so we shift everything up. We multiply 6 times our 231.54. We get 1389.24. The next thing we do is we add them all together. And the last thing we got to do is figure out where we're going to put that decimal. We determine that by adding the original number's decimal point together. In this case, we have 3 decimal places. Okay? 1, 2, 3. We move our decimal point from the very end of the number forward 3 places. And then it is solved. Does that make sense? Okay? Questions? Nobody? All right. So I'll give y'all one to work on your own real quick. Like I said, I'm trying to get through this as fast as possible for y'all because I know most of y'all, this is just a review, right? And guys, I do have these same lessons more in depth from previous runs of this class if y'all want to listen to those if you find yourself confused. I'm going to move it and post it and have all sorts of fun with it doing that on YouTube. Okay? What is wrong with this cable? Everybody done? Anybody need a minute? All right, give y'all just another minute. Everybody good? All right. And that should have been your answer. 3,996.642. All right. So, again, the only term I would say you need to know, just simply because, is quotient. I don't know why they called it quotient, but they called it quotient. It's not the number that you got as your answer. Again, I've had math problems that say, find the quotient. But you can't just say, take these two numbers, divide them, and give me the answer. No, we're going to have to be complicated about it and say, find the quotient. All right. And then the other term is remainder. That should be very familiar to a lot of people. And all of y'all probably hated that term, right? Because that was the evil term. That was the, how much did you have left after you finished dividing it term. All right. So, I'm going to go ahead and tell you, I'm not going to require long division, guys. Long division is too long. All right, if I do give y'all division, it's going to be very simple problems. Why? Because getting overly complicated with long division is evil. I leave that mostly to algebra and things like that. So, do y'all know where to start when you're if you do have to divide with decimals? Just to kind of give y'all a bit of a refresh with this, anytime you divide with decimals, for those of you that might not remember, and do remember, anything you do to one number, you have to do to what? I have to do to the other. So if I want to get rid of my decimals and say 17586, I'm going to have to divide that by 120. Why? Because I moved the decimal 2 places on my top number, so I have to move it 2 places on my bottom number. Does that make sense? Yes? All right. So if I was to solve this by hand, I should end up with a 1, be subtracting 120. That's 5, bring down the 8. And you should be able to do that 4 times. And then you should end up with a remainder of, not a remainder yet. So 8 minus 0 is 8. This one would be, so you have 7, 8, bring down the 6. That should be 6 times that goes into it. You end up with 720. 786 minus 720 should give you 460, at which point you've placed your decimal. Goes into 460 5 times. I'm sorry, it's not 460, it's why I don't like trying to do this on the fly. It should be 660. Bring down your 60, another 5. You should end up with your total being 146.55. Yeah, trying to do long division on the fly is a little bit harder than what it used to be. So 146.55, got that by doing strictly long division. I'm not going to ask something very complicated if y'all have to do something like that. And that's it for the decimal point, because the rest of this is we're about to go on the next slide. Set. Okay. Any questions on this, guys? Before I let y'all take a break. And then when we come back, we'll do ratios and proportions, and we'll move on to